Good morning. Happy Wednesday. Welcome to more filling and wrapping. Yesterday, you guys talked about how to find the volume and surface area of cylinders, which was fantastic. And you learned how to calculate the area and circumference of a circle. And if you do not remember how to do that, then you should really go back and check out Mr. Vampy's videos, add to the 200,000 views that he already has. For the warm-up, we've got 3 rectangular prisms. Pause the video, take a couple minutes, find the volume of each of these, and then go ahead and hit start again on the video as you see me solving them. Remember, to find volume, we go length times width times height. I do need to apologize. I only have the scroll pad on my laptop to write things, so my handwriting will be definitely off, and I am sorry for that. I will make it as legible as possible. And as you can hear, I've got my cute child in the background. He just wanted to say hi to you guys. Want to say hi, buddy? And he is waving, which he just learned, which is super cute. All right, so for the first one, I've got a volume of 10 times 4. 10 times 4 is 40. Times 4 is 160. And let's just call these units. Remember, when you talk about volume, we are cubed. Over here, you should be able to do these all in your head. If I think about how I can multiply these, if I multiply the 5 and the 4 first, that's going to be 20. And then I multiply 20 times 18. Really, I'm just multiplying the 2 times 18, which is 36, and I add the 0, so it's 360 meters cubed. Up here, I have a 3 by 3 by 3 cubed, so 3 times 3 is 9, times 3 is 27. Again, that would be in cubic units. So we can say U cubed. Yesterday, you guys worked on your checkup. Here are the answers that you should have come with. If you rounded to a different number than this, then know that your answers for problem number 2 will be slightly different, but that is totally fine. Remember, volume is length times width times height. Notice how I have my units in here because I'm multiplying inches by inches by inches, therefore it is inches cubed. Down here for surface area, I decided to find the area of one side, of 2 sides, and of the third side, and then multiply it all by 2. If you wanted to multiply this by 2, and then add it to multiply this by 2, and then add it to this multiply by 2, add them all together, so you get the same answer. And then notice we have inches squared here because we were talking about surface area. You should think about wrapping paper, goes around the outside. If something is holding it, it's on the inside. So that would be my volume there. Going to number 2. This is where I would love to see you going. Many of you probably did this second line here. Many of you did this because you figured out something. At least I hope you did. And what you figured out is that, remember the equations we worked with perimeter and area, and how when we had area of the original times the scale factor squared, that gave me my new area in square units, or the perimeter times scale factor gave me my new perimeter. Well, when we talk about volume, it's the similar idea that, I don't know why this doesn't have an L, I apologize for that. Original. When you talk about volume, it's the similar idea that volume is in cubic units, therefore my scale factor must be cubed to give me my new volume. So as we think about this problem here, the simple way to do it would be to take the original volume, which we got from the previous problem, which was this number here, multiply it by the scale factor cubed, and that gives my new volume. What I was really looking for here and how many times greater, that you would actually tell me that that is 512 times greater. 512 is 8 times 8 times 8. When I come down here and I talk about surface area, now again I'm talking about area. An area is a squared term, and so then for my scale factor should be squared. And ideally we're looking for 64 times greater. If you gave me the actual new area of that, that is fine. But we need to be getting to these two places right here, this one and this one, for this lesson. On the back side, we see that a pool table, blah, 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 and it talks about boxes. And if I'm looking for the one with the most cardboard, I want the most surface area, the least cube-like, so therefore the 16 by 1 by 1. And if I want the one with the least amount of cardboard, I'm looking for the most cube-like, and that's going to be the least amount of surface area, so that's 4 by 2 by 2. If you said something along the lines of the smallest range between all three numbers, that would also tell me that is going to be the most cube-like. Either of those works great for this.